All right. Hello, everybody, and thank you for joining us for this session titled Optimizing Data Lakehouse Performance, Leveraging Dremio's SQL Query Engine, Lakehouse Management Features, and Apache Iceberg for Scalable Analytics. My name is Jason Love from Dremio, and I'll be your moderator for this session. Before we start, just a few housekeeping items that after the presentation, we'll have a live Q&A. So be sure to use the chat tab to ask any questions and engage with your fellow attendees. If you need support, we have a help desk ready to help you anytime. With that, I'd like to welcome our first speaker, Balaji Ramaswamy, Advanced Support Director at Dremio. Balaji, I'll hand it over to you.
Hey, hi everybody, welcome. I would like to go over some, really cool optimization techniques that, that really help your queries run fast. In addition to your regular, the SQL plan that Dremio or any other tool generates. Now, the concept that I'm going to say are probably applicable to any tool, but definitely in the Dremio land, it's like very, very useful. I would like to go start sharing my screen. So you should be able to see my screen now. And the first thing I want to touch upon is the, Iceberg partition transforms, right? Before we go into the actual partition transformation, let's take a step back and look at why partitioning is so useful in lakehouses, right? So customers and businesses can have tons of data. They can have tons and tons of data. But what is important for a dashboard to load in a sub-second is how less of data you scan, because most of these dashboard queries are like, hey, give me the the number of loans sold across the US states, right? So you're pretty much selecting one column, the state code or the state name, and then you're grouping by the count of the loans sold. And usually these queries should come back very fast, and that depends on how well your data is partitioned. So let's take a step back and look at how we partition in before the birth of Iceberg, right? Before the birth of Iceberg, and this is just the Apache Iceberg documentation that I'm looking at, you would see that often queries just come in like, hey, give me all the, say for example, there's a log file that has a lot of messages, right? Give me all the messages from the logs table where the event time is, between say 12:01 and between 2 hours. Now, if there was no Iceberg partition transform, which I'm going to explain in a bit, we typically would struggle to find a partition column for this query, because you really don't want to partition on the timestamp column, because there's going to be way too many files and folders created, because it is a very, very high cardinality column, because every second will be a new partition, right? So how would we have done this in the old school, right? What we would have done is something like this, where there would have been a column called event date, and the event date would have it will be a partition column. And then you would hope that the incoming query will have the event date in the filter so that it could only go to that partition. Now, if you look at this query closely, there are two things. One is you have to remember to partition on a different column than what your actual filter is. The actual filter is on timestamp, but actually you're partitioning on event date. The second thing that you can observe is you have added both event time and event date in your filter, because you have to force the partition, right? So these were some of the challenges that people had, because the ETL would partition on a certain way on the timestamp column, but the actual reporting from the business user may be on a different format on the same timestamp column. So what did Iceberg do? So Iceberg went ahead and said, hey, you know what? You create the partition on the timestamp column, but you can use a function on it, which is year, month, day, or hour. Even though in the raw storage or on S3 or on HDFS or Google's cloud storage or Azure storage, you have it on year. So if you do it on day wise, it would have one folder per day. But you can still use your original query that I was talking about here, where you can pretty much give a timestamp. and it would go and figure out what exact data files to read. And to just show an example, here is a Dremio profile, which usually gives you that information, right? So if you see here, I have, oh, this is the bucket help. So let me go look at this timestamp. Yeah. So if you look at this, the table is created on month of TS. And then if you look at the actual SQL, it would be the developer has, or the business user has no clue on where the partition, on what type of transformation it is. But then if you go look at the number of files read, it is just 2, right? So there were many more rows recorded, and Dremio actually gives a lot of information into how much was scanned. And so if you go look at this, you would only see 2 data files scanned. So that is the beauty about Iceberg partition transforms. And there are a couple of other ways where you can do this, is using a truncate, where you can say that, hey, I want to create the partition on the first name or the country, right? But there are so many countries in the world that would be too high cardinality. But you can do, on the first letter of each country, and which would be maximum 26, right? So if you go see this example that I've given, you can actually go create it on truncate of country, and then I have Sweden, Germany, USA. You see, so there'll be 3 buckets created, right? One for S, one for G, or one for U, because I have given 1 comma country. And then if you go actually look at the query, just like how we exactly went and read only the 2 files for the timestamp, you go look here, even though, so when you say Sweden, it would go and exactly look at the 2 data files, right? It would not look at all the 7 data files. Now, in the backend, if you go look, you would see that there is a partition for the 3, where is it? Yeah. So if you see here, there is a partition for the G for Germany, S for Sweden, U for USA. So Iceberg completely abstracts what we should partition on. We can pretty much have so much options that you can partition on a high cardinality column or a low cardinality column. The other very useful one is the bucket, which you can even use on an ID column. So then there'll be, based on what the value for n is, there'll be enough buckets created, and like these. And then what you could pretty much do is you can run a query. This is truncate. So there should be one for bucket. So you can create the partition on bucket and insert how many ever rows you want, and you can give a query that actually goes against an ID column. So if you go look at this query, it actually goes through the ID column, right? And this will again use partition pruning. And even though ID is a high cardinality column, because we have bucketed this, you go look, it'll only read 1 data file. Super fast. Now, the next topic, which is kind of a continuation of partition transforms, is partition evolution. And the bottom line in partition evolution is, when the project went live, or the system went live, it was done on month of TS because there was not much data, right? And every month, the number of files that were there were not much. Now, with a lot of use cases getting onboarded into production, or more kind of people using the system, that was unmanageable because there was too many data files per month and the scan was taking too long. What do you do in the old legacy way is you have to actually drop the partition on month and recreate the entire partition on day. And not only that, you have to change all your queries now to use the new method, right? Both are avoided with Iceberg. You can simply add a new partition, And if you see, the old partitions will go off month, so the scan will be slightly more, or there'll be less data files. But the new incoming queries will partition by day and only scan that day. And in the backend also, if you actually go look at the describe table, you would actually see both partitions. So that actually gives you a lot of options to change partitioning scheme as the data pattern and usage changes over time. And the best part is you don't have to change your query and you don't have to touch your old partitions. So that is super good. The final topic I would like to go over, which is one of my all-time favorites, is the concept of runtime filtering. Now, this is not specific to Iceberg. It will work with Parquet 2. And what this basically does is, when there is a join, and the join is between a small dimension table to a large fact table. Now, typically when you join these two tables, the filter will be on a partition column on the dimension side. So the join column could be different, but the filter column will be different. And usually it'll be a subquery. So you are selecting from the large fact table where the column name in, and you're trying to run a select of the dimension table, and the dimension table has a filter on the partition column. Now there directly the fact table will not benefit from partition pruning, because because during planning we do not know what partition values are going to come over from the dimension side. So what we rely on is something called as runtime filtering, where once the build side, which is the dimension side, finishes, it will have the partition values passed over to the fact side. And before the fact side scan can even start, those partition values will be applied during runtime, and your query will be super fast. Now, I want to show an example of how when runtime filtering kicks in, it's super fast, and when runtime filtering does not kick in, it actually the query may also not finish, right? It's that kind of optimization that it can bring into the table. So let me show you that. So if you see here, this query finished in 1 minute and 7 seconds, large fact table. So if you look at this, it's a multi-way join with one of the biggest tables on the leftmost side, which is this. And if that table has to be scanned completely, then this query will never finish, right? And how do we effectively only scan what is required for this table function is you go and look at something called as runtime filtering. So runtime filtering usually happens on the join, and it happens on the join between the build side and the probe side, and the build side being always a dimension table and the probe side being a large fact table. And when you look at the runtime filtering, it says that it's applied on 5.2, so let's go look at that table, right? And if you see this table, some of these rows are large and some are not, and that's because runtime filtering has come in, and you can see how many partitions were pruned, right? So you go search for num partitions pruned, you can see so many partitions getting pruned. And if runtime filtering did not kick in or was not effective, this fact side table would be scanning all these 50,000 partitions. That's how the scan became super quick. If not, the scan would be forever. For example, I can show a scenario where runtime filtering did not kick in. And the user had to just cancel the query, right? So it is very critical for us when we do joins and when we do a join on a small table is to a big table, runtime filtering is very, very important. Now, there is one more slight alternative to runtime filtering, and I want to talk about that for a couple of minutes, right? So what happens when the filter and the join columns are the same? So for example, if you're joining, say, employee and department, and you're joining on department ID, and you're also filtering in department ID. So if you remember, in runtime filtering, I said the join will not be on the partition column. The join will be on a foreign key kind of primary key combination, but the filter is on a partition column so that the query is fast. But in this case, the join is on the foreign key primary key relationship, and the filter is also on the same column. In this scenario, we don't have to rely on the dynamic runtime filtering. During planning itself, this filter can be applied on both sides because it is the join column, and it's probably a step above, I would say, right? So if you go look at this query, again, as I iterated, it is joining on department ID on both sides, and we're filtering on department ID. So if you go look at the plan and you look at the two filters, this is the employee table. You have the filter on the department ID here. You also are having the same filter on the department side. So this filter gets applied on both sides. So this way, effectively, you don't have to remember which side the filter needs to be applied. The planner will take care of it. Subtle difference between runtime filtering and this, where runtime filtering kicks in when the join column and the filter column are slightly different. Now one more thing I kind of missed is, it's not necessary that the filter should be on the partitioning column for runtime filtering. It can as well be on a non-partition column filter. So what is the difference? When you have it on a non-partition column, you will not have partitions pruned because you don't have it on a partition column, but you will still have pages pruned. So based on the runtime filter that comes on the big fact table, which we call it as the probe side, there will be pages on the parquet footer that will be skipped. So that way, effectively, you don't have to read all the pages of the parquet file. So I might have an example on that. So so basically this is a partition column. You can see that this is true, but generally if you have a non-partition column, you will have that column also listed here as a non-partition column, and you can see the number of, so if you go how we were looking at pages pruned, you can say num pages pruned, and that will be a very high number. In this case it's 0 because there was no non-partition column filter used. Cool. So basically the three topics we discussed about partition transform, and in partition transform, I just want to recap. We can do it on days, months, hour, and year of timestamp, or you can do truncate. We looked at the other example of bucketing, right? And then we also looked at how partition evolution is super important, because that kind of allows you to change the partition scheme based on how the data pattern has changed. So both of them help you in both optimizing your Lakehouse features by making your query run fast. And finally, we touched upon runtime filtering, where during runtime your query can be accelerated by pruning partitions or pages depending on a partition column and a non-partition